Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new to my channel, I pretty much do LeetCode style questions and try to explain things in the most simplistic way possible. And today I have this interesting problem for you guys. It's called the binary tree right side view, right? Let's read the problem statement. So given a binary tree, right, they're asking us to imagine ourselves being on the right side of the tree, right? And our task is pretty much find a way to return all the values of all the nodes that you are able to see, right? From top to bottom. So let's imagine ourselves right here, right? 1, 3, and 4 would be the nodes that I will be able to see, right? I'll be able to see 1, I'll be able to see 3, and I will be able to see 4, right? That's why we have this in the output, right? Because I won't be able to see 2 because 3 is blocking 2. I won't be able to see 5 because 4 is blocking 5, right? So by looking at this, we can see that if we're going to traverse the tree, level by level, and from left to right, we can see that the element that I'm able to see at each level is the last element, right? Because yeah, that's why we see 1, 3, 4, right? That's kind of the intuition that I came up with when I first started seeing this question, right? When I first saw this question, if 4 wasn't there, right, I would have been able to see 5 because 4 wouldn't 4 is not there, so therefore 5 is the only element at that level. So I will be able to see 5 because I'm looking straight through, right? So we're gonna do it in a level by level, right? And then the last element at each level is gonna be the node that I'm gonna include in my output list. So this is a breadth first search approach, right? BFS. This thing can also be solved by using DFS, the depth first search. Depth first search goes deep one way, and breadth first search goes level by level. Now those are the two really good famous algorithms that are used to traverse trees and graphs, right? So we're gonna use the breadth first search approach. So let's go ahead and code that up really quick. So I'll explain it as I go through as well, right? So since we decided that we're going with the queue, right? So the breadth first search, so we're gonna need a queue, right? The queue of tree nodes, right? So we're gonna name it queue. And then so now that we have our queue, right, the next thing that we need to worry about is to have our output list, because we have to return a list of integers, right? So that's why we're gonna have this of integers. So we got a list of integers, res, I call it res, and new array list, right? So this is what we're gonna populate to return back to the caller, right? So before we get started, right, we need to make sure that we're given the root that we're given is a valid node, right? Because if there's no valid tree, we won't be able to process it, right? So if the root is null, right, we automatically return, right, empty list. All right, so you gave me a bad binary tree or a non-existent one. There's nothing we process, so I'm gonna return an empty list, right? So once we've established we got a binary tree, now we're gonna do the algorithm that we talked about. So first things first, we add the root to the queue, right, for the process, and then we're gonna have a while loop that we're gonna use to, while we'll still have nodes to be processed, we're gonna stay inside of this. This while loop, right? And yeah, so at each level, right? So we take the size of it, right? Take the size of the current level that we're at, right? So right now, we start off with the first level. The first level is 1, right? So that's why size will equal to 1, right? So we take the size, right, for this particular level, right? So it'll make even more sense to have level size, right? Make it more descriptive, right? So, and then once we have that, we're gonna have this for loop that's gonna iterate through all the way to the level, to all the nodes that's included in that level, particular level that we're on. So I equals 0, I is less than level I plus plus, right? So now that we have that, now this is where the magic, really happens, right? So now we're gonna take one node. So we're gonna keep processing one node at a time, right? And then we're gonna name this node, and we're gonna take that node out of the queue, right? So we take one out, right? And then this is a very, very important, right? So let's just do this first. So if node that left, right? If this particular node has a left child, right? We add it to the queue, right? Because we want to process it as well, because that's gonna help us for the next level, right? So for one, left the child's not null, so we'll add 2 to add 2 to the queue, right? And then we also do the same check for the right? We do the same check for the right child, right? So we got that right. And then so it checks that if there's a right child, it adds it to the queue as well for it to be processed. This is a pretty much the same template that you would use for there's a lot of different BFS problems that you could practice. You can see it's the same setup that you use eventually, right? So after we check the right child, right? Now the most important thing, right, which is going to help us to build the output list, we check this current iteration that we're at, right? Is it equal to level? Is it the last element in that particular level, right? So right now for the first iteration, right, I is equal to 0, right? I is less than level that size. So right now I is 0, and then level size is 1, right? But since it goes up to level that size minus 1, if it's equal to the last element, then that's what we add that element to the output list, right? So now that we have that, we're gonna add that particular node, right? Node that val, right? So let's say for this example, now left is not null, we add it, we add 2, right? Right is not null, we add 3, right? And then we check, is 1 the last element for that level? Yes, it is. Then we add 1 to it, right? And then we go on to the next level. It checks this level size is of size 2, right? So you start off, so you check, you take 2 out because 2 is the next element to be processed. It checks the left child, that's null, so it doesn't add it. It checks the right child, is not null, 5, we add 5 to the queue. And then we check that's the last element for that level, right? Nope, it's not. So you go on and then do 3. 3 does the same thing, checks if it's the last element. Yes, it is like the last element. Then we add the actual value to it, right? And then so once we have that, we're pretty much set. We're pretty much home free. So the next thing is to pretty much return the result to the caller. So let's try to run it real quick. See if we got it right. All right, looks like everything went through. So let's check, all the test cases. All right, that's perfect. So it seems like everything went through, right? So yeah, this question is pretty interesting question, right? It's not very tricky, just need to know the algorithms, like the breadth first search, pretty much doing things level by level. You need to use a queue, and the queue is gonna help you process the things in order, right? In order to receive, right? And then we do it level by level, and we take the size of every level, right? And then we process all the nodes in that level, right? And then we take the last element in that level and we add it to the output list, because you know that's what we those are the nodes that we want, right? Yeah, guys, that's pretty simple question. So yeah, guys, let me know in the comment section if I did a pretty good job. You know, if you guys are new to this channel, please subscribe, because I'll be making a lot more content like this. And yeah, let me know any feedback. I'm open to it. So yeah, I'll see you guys in the next video. Thank you.